Hello everyone, welcome to IS 300. Today we talk about one of my favorite topics, the Internet of Things. We focus this week on connectivity standards that are primarily used by IoT, also known as the Internet of Things. The key words that you should understand in this chapter are the communication standards, Bluetooth Low Energy, also known as BLE, Zigbee, 6 Low PAN, Wi-Fi, and LoRa, which stands for long range. The Internet of Things, here is the definition. Uniquely identifiable embedded computing devices or things, hence the name, things that can be connected to the internet or to each other. IoT devices can be monitored. You can get performance data from them. They can be controlled remotely, and they can collaborate with each other. It is a multi-trillion-dollar industry, more than $9 trillion, I believe, last year, and only growing in 2021. There are wearable devices, allows everything, physical things rather, to be connected to the cyber world. Of course, the risk inherent with that is the risk of security breaches and hacks has become greater because of IoT. It connects the physical world with the virtual world. It combines IT with the industry and is referred to as the Industrial Internet of Things. It starts by connecting devices and then monitoring various conditions of the device, looks at the data to gain some useful insights about performance, and leverages performance data so that you can control autonomously the devices to achieve desirable outcomes. Like most cloud-based architectures or most IT architectures in general, they use a layered approach. The things layer at the bottom of the stack, the network layer, which is gateways, hubs, routers, and things of that nature, and then the application is at the top layer, which basically allows for the connectivity parameters, the configuration, how the device actually runs, the programming of the device at the application layer. The standards that are implemented at each layer, local area network standards, Wi-Fi 802.11, Ethernet 802.3. Then you have personal area network standards, 802.15.4, Bluetooth, Zigbee, and 6 Low WPAN, or wide area network standards that are listed here. Bluetooth, which we are all familiar with Bluetooth, has a variety of uses. Typically, it is Bluetooth Low Energy, which was designed to reduce power consumption. The newest version of Bluetooth developed in 2017, with more devices being introduced with Bluetooth technology all the time. It has a central device and peripheral devices. Here's some examples. Of course, we know about smartphones and smartwatches. Most of us have them. A computer or laptop that is Bluetooth enabled. You might have some appliances, light bulbs, and technologies, thermostats, and what have you that might use Bluetooth and or Bluetooth headphones and headsets. All of these devices are Bluetooth. They are short-range, low-power devices. You can broadcast, or there's broadcast mode or connect mode. You can advertise the packets or send response packets. Either one of those technologies will work with Bluetooth. Zigbee, which is a competitor to Bluetooth, is also based on 802.15.4, the standard. It is a low-rate wireless personal area network standard, short range, low cost, low power, limited memory, used for personal area networks, thermostats, and smart locks and devices of that nature typically will incorporate Zigbee technology. If you have an Amazon Echo, it might control a Zigbee device. Here's the protocol stack for Zigbee. Notice that it's got 802.11 right there in the middle, which is Wi-Fi. Also 802.15.4, which is most of the wireless personal area network standards. Here's the stack for Zigbee. Got an application layer, 802.15, which is the protocol layer, data link and or physical network layer, API, and application programming interface. All of these Internet of Things technologies will be connected typically using an API, and then the application itself at the top of the stack. Then there's something called 6-Low WPAN, which is IP version 6 over low power wireless personal area network. Those of you who are understanding of network technology know that IP version 6 is the protocol that's used for high-speed internet usually. There's IP version 4 and IP version 6. IP version 6, 120-bit addresses, where IP version 4 is only 32-bit addresses, and so IP version 6 typically used in very large networks where you need a lot of IP addresses. 802.15 and IP version 6 is the 6-Low WPAN standard that we're talking about here. We also have packet size of 127 bytes. The other byte is used for header and connection information. Sleeps most of the time to save energy, and it adopts the bottom two layers from 802.15.4. The bottom two layers, if you will recall, are the data link layer and the physical layer. So here's an example. You can use 6-Low PAN primarily for medical devices, wearable heart monitors, and things of that nature, which then would connect to a router. The router would connect to either a 3G, 4G, or maybe even a 5G network now, which connects to the internet and allows the doctors and or medical experts to analyze the data that's coming from that wearable device. Very common these days, and also very innovative. This is the protocol stack for 6-Low PAN, and it is, if you are familiar with the OSI 7-layer reference model, this is a 5-layer reference model, which introduces the application layer at the top of the stack, then the transport layer, TCP and or UDP, the network layer, which is IP, in this case, IP version 6, the adaptation layer, the MAC layer, and the physical layer at the bottom of the stack. Again, most of these technologies will implement some sort of a stack, either 3 layers. In this case, you have 5 layers, but it's always a layered approach. Here's a combination of Zigbee versus 6-Low PAN, and it shows you the differences between those two standards. Wi-Fi of course, is a natural evolution in terms of IoT. The coverage is ubiquitous, which means 24/7, 365, any place, anytime, and it can accommodate real-time video surveillance, wearable devices, weather forecasting, offshore oil and gas pipeline monitoring, and things of that nature. It is becoming very, very important in terms of climate control and the environment. Using Wi-Fi and IoT gives us a lot of usable information that we can make decisions with, and that we can use for forecasting and things of that nature. Low RA, or low range, is also a wireless communication protocol. Low power wide area network protocol, which is a wide area network protocol, which means it's long distances, and it offers a variety of different data rates depending upon where you are. Notice that in Europe, 866 megahertz, 915 megahertz in North America, 433 megahertz in Asia. So different parts of the world use different frequencies and different speeds. This is a pretty good diagram that sums up the use of IoT devices in the real world. You have the cloud server in blue and some long-range communication standards and or short-range communication standards. The short range being Bluetooth, Zigbee, 6LoWPAN. You also have some computing devices, edge computing devices, which we'll talk about in later chapters. Smart education, smart city, smart healthcare, smart transportation. All of those things are possible because of IoT, and the end users are, it can be a car, it can be a smartphone or an iPad or some sort of device like that. It can be a smart city with a grid of power and or electrical grids that are being monitored. It can also be medical devices that can track and monitor the ability to record information, vital signs, and things of that nature. Very useful, very innovative, and we have only skimmed the surface in terms of the capabilities of IoT technologies. It is the wave of the future. Industrial IoT, enterprise IoT, wireless IoT, all of those are things that we will talk about in future chapters. Let me know if you have any questions.